So the first one we're going to hear from is VividQ. So I'll welcome Darren from VividQ.
I'm mic'd up. Good morning, all. Thank you for coming out to see us. So, yes, I'm Darren from VividQ, and today I'm going to present to you one of the most important and critical advances in display technology for augmented and virtual reality. This is holographic display, which I will explain, and this gives you full 3D images with an accurate and true sense of depth in the scene. Okay. So let's have a look at what that means. So at this point, I need a bit of audience participation. So if everyone could hold out a finger in front of their face. Okay, I want you to look at the finger. Okay, you should notice that everything in the background goes kind of fuzzy and out of focus. Now look at the background. Now the finger should go out of focus. Okay, this is a very natural response. This is the lens in your eye accommodating to be able to see different things in focus. And it's critical for your ability to spatially locate things within your environment. However, this is a sense entirely missing from the current crop of 3D technologies, whether that be 3D TV, 3D cinema, heads-up displays in cars, all the way through to the latest and greatest in mixed reality with the HoloLens and the Magic Leap. So if you look on the left, this is what you see through an AR headset today. You have two objects. The perspective tells you that one of the apples is further away because it's smaller. But your sense of focus is telling you actually they're the same place, they're the same focal plane. This is kind of unacceptable if you want a full mixed reality effect because it doesn't allow the objects to blend seamlessly with the environment. This is solved with a holographic display since it generates full 3D images with the sense of depth intact. So today, we are very excited to present the world's first ever fully holographic headset running on VividQ technology. We're presenting this for the first time here at Web Summit. It's available at our booth in G107, where you can come and actually try for the first time a fully holographic experience where you can see images in full depth. So, in a short video here, just show it. So this is the headset up close. It's a monocular set, so we only use one eye. One eye is enough to get a full 3D image as long as you're presenting a 3D image. We take data straight out of a game engine like Unity. Here you can see two elephants in the scene. You can see it's 3D. They're clearly spatially separated. And then we extract that data directly, and we can load it through our algorithms to compute a hologram. This is then loaded onto the headset, which our user will then put on their head. And then when she looks through the headset, she'll see those elephants brought to life as holograms. And you'll see what I mean in a moment. So as she looks at the headset, she sees the two elephants in her field of view, and they appear to sit at different depths. So here, your front elephant is clearly in focus with a hand. The back elephant is clearly out of focus, in focus of the background. Here we're using a camera. As we change the focus of the camera, the elephant in the background snaps into focus. This cannot be done on current AR, MR devices. This makes interaction so much easier. Half of their ability to reach out and touch and interact with objects is based on your sense of focus, and since that's absent from most current devices, that's impossible to do. So, what is a hologram then? A hologram is a way of shaping light to make an image. So if we take an example, let's take this clicker for example. When we look at this, we're not really looking at the object as such, we're seeing light reflected off it and hitting our eye. And if you were to build the perfect display device, what you'd want to do is mimic that process. I'd want to compute the reflected light off there, somehow present that on a display, and then show that to the eye. And in that sense, I would have created a perfect visual illusion that exactly mimics the device with all the 3D cues intact. So this is what we do. Our software computes an interference pattern that allows us to shape the light. We then present that on a specific micro display, shine some light on it, and the reflected image gives us a holographic image. So inside the headset, it's rather simple. All the magic really happens in the software. The optical apparatus sitting in here is just a laser pointed at a display. Then everything beyond the display is just some optics to guide the beam to the image to your eye. I should say that presenting in a package this compact has never been done before. Usually if you look at a holographic display, it takes up an entire bench. So a lot of the work we've been doing has been shrinking that down to something head mountable. So this is where VividQ sits. There's 3D content, there's a wealth of it from game engines, CAD systems, 3D cameras, and there is hardware available to show holographic images. We are the software that sits in between, and that software is powering this headset. The applications are pretty endless, so because we're creating genuine 3D image, we're not restricted to the headset. We can get heads-up displays or desktop displays. Again, 3D displays where multiple people can view the same image from different perspectives and see a full 3D image. Okay, so I will wrap up there. Thank you for your attention. So if you'd like to come and see us, we are at booth G107. You can try out the headset there. You can see the first full-depth augmented reality experience. Thank you very much.
Okay, thank you very much. So do we have questions? Let's see what the, okay. We'll start with the pretty basic one. What's the use for this?
So I guess the question is, what's the use of augmented or mixed reality? Because this is really a technology that enables that and improves it, and that's found in many uses, whether that's industrial or gaming or a variety of consumer uses. We sit a little farther back from the application in that we're one of the software enablers allowing mixed reality to become a thing. So the use is mixed reality, but later on, when we expand into non-headset based devices, then heads-up displays for cars, infotainment systems, desktop systems, so say if you wanted holographic teleconferencing where you can see a hologram of a guy standing on a desk in front of you.
Okay. And how much is this product? What does it cost?
So we don't actually sell this product. This is just a prototype to demo our software. We are working with hardware manufacturers who are creating more consumer-friendly products, and we sell the software package to them. The SDK is around about £4,000.
Okay, well that kind of answers the question, who do you sell to then?
Yeah, sure.
I think we've kind of addressed that. Current state-of-the-art MR devices use gaze recognition and 3D environment estimation. Why can't you blur the object with respect to the gaze and distance?
You can, but then you need to do a lot of eye tracking, which adds a lot to your compute, and current eye tracking isn't really that great at depth of field. It can track where your eye is in that space, but not in that space so well. And this totally circumvents that problem. Why bother presenting your eye with 2D information that you need to alter when you can just give it 3D information that it expects?
Okay, well that's all of our questions, so thank you very much.
Thank you.